Okay, Assalamualaikum and good afternoon, everyone. So for today's lecture, Salam. Okay, so for today's lecture, we will continue on slide chapter 4C regarding root locus. So in video number 1, I have discussed all the questions that are given to you as quiz 12. Okay, so for today we will continue some maybe 2 more questions that are in the chapter 4C slides. Okay, so question, I think this is the third question. So same thing, you are given a block diagram. So this is unity feedback. Okay, so unity feedback with feedback transfer function equals 1. Okay, so here HS equals 1 and the top one is GS. Okay, so the question is quite standard, okay, in the slides. So the first question asks you to find the exact point and gain where the locus crosses JW axis, and then find the breakaway point on the real axis, and also the range of K for the system to be stable. Okay, so let's look at how to answer this question. Okay, so the transfer function is GS equals K S squared minus 4S plus 20 divided by so plus 20 divided by S plus 2 times S plus 4. Okay, so in quiz 12, I already list all the necessary steps to follow for to answer root locus. Okay, so the first step is to determine the finite poles and zeros. Okay, so you need to determine finite poles and zeros from the transfer function. Okay, so because this is unity feedback, so you only need to use GS is enough to determine the finite poles and zeros. But if it's not unity feedback, then you need to find the closed loop transfer function first, and then determine the finite poles and zeros. Okay, so first step is to determine poles and zeros. So step 1, poles. So we look at the denominator. So S equals minus 2 and minus 4. Okay, so from denominator, the poles. And then you determine zeros. So zeros from the numerator. Okay, so you get then you use quadratic formula to get S equals 2 plus minus 4J. Okay. Okay, so 2 plus minus 4J. And the first rule says that the number of branches equals to the number of poles or zeros, whichever has the most. Okay, so here you have 2 poles and 2 zeros, meaning that you have 2 branches. Okay, so maybe you can put a conclusion 2 branches. Okay, so you don't need to add infinity poles or zeros because both of them have the same number of poles and zeros. Okay. All right. So next, based on the question, you are required to find the exact point and gain where the locus crosses JW axis, meaning that you need to find JW axis crossing, okay, the frequency and also the gain. So basically, we follow step number 5. Okay. To determine JW crossing, we use route Hurwitz criterion. Okay, so the first step you need to do is you need to get the closed loop transfer function. Okay, so TCL equals K times S square minus 4S plus 20 divided by S plus 2, S plus 4 plus K S square minus 4S plus 20. Okay, so you take the denominator and then the denominator equals S square K plus 1 S square plus 6 minus 4 K S plus 8 plus 20 K. Okay. Then from here, you need to do route Hurwitz table. So we start with S square. Then followed by S1. Okay, so here is K plus 1. And then here is 6 minus 4K. And here is 8 plus 20K. And here 0. And for S naught, you do the determinant, calculate the determinant. So you get 8 plus 20K. Okay. All right, from here, you need to determine the gain K at JW axis crossing. So to determine gain K, you need to use the row S1. Okay, so use row S1. So 6 minus 4K equals 0. So you get K equals 3/2. And then you use this value K and substitute into row S2 to get the frequency. Okay. So use row S2. So you get 3/2 plus 1 S square plus 8 plus 20 times 3/2 equals 0. Then you simplify and solve for S. So you get S equals plus minus 3.9 J. Okay, so this is the JW axis crossing. And this is the gain at JW axis crossing. Okay. And then the next step, the next question asks about finding the breakaway point. Okay, so for breakaway point, you use rules number 6. Rule number 6, the breakaway point can be determined by finding the sum of 1 over sigma minus z equals sum of 1 over sigma minus pole, 0 and minus pole. Okay, so let's find the breakaway point. So our poles is -2 and -4. So 1 over s plus 2 plus 1 over s plus 4 equals, so the zeros are 2 plus minus 4j. So you have 1 over s minus 2 minus 4j, and also 1 over s minus 2 plus 4j. And then you simplify this, okay? So you'll get s square minus 4s plus 20 s plus 2 plus s plus 4 equals okay. So in the quiz note, I put sigma, okay? So you can use whatever symbol as long as you understand that this s or sigma is the breakaway point that you are going to determine, okay? So simplify this, you will get okay, then further simplify, you will get okay, so you get a quadratic equation. Then the breakaway point will be at negative 2.88 or at 5.28. Okay, so this is the breakaway point. Okay, so this is question number 2. Soalan tak suruh sketch. Okay, ada sketch tu dah hilang. Okay, then you can sketch the root locus, okay, based on this information. So root locus. Okay, so we have first we plot the poles and zeros. So minus 2 minus 4 and 2 plus minus 4j. So so minus 2 somewhere here. This is minus 4. So this is poles. This is the second pole. And then plus 2 plus 4j. So 1, 2 somewhere here. 1, 2, 3, 4. So the zeros are here and here. And then you already have the JW axis crossing. So S at 3.9j plus minus. So it will be somewhere here. And then you also found the breakaway point. One is at minus 2.88, somewhere here. And the other one is at 5.28. Maybe here. Okay, and then, okay, that's all the points that you have found. So we can sketch the root locus. So the root locus, if you look at the rules, it must start at poles, and finish or ends at zeros. Okay, that's the first rule. And then the second rule, it must be symmetry about real axis. So your root locus must start from x, okay? Must start from this x and then going to the zero or the zero here. And you also know that there are two branches. Okay, from rules number 1, you found 2 branches. You found that the root locus must have 2 branches. Okay, so there are 2 branches and start from the poles going to the zero. So the only way possible is the root locus must start here and then go to this breakaway point, and this root locus start from here as well, goes to the breakaway point, and then both of them will split, one going up, one going down, and then cross the JW axis crossing, and then meet at the zero. Okay, so let's try sketch. Okay, so we'll start here. Alah. Buruk lukisan. So somewhere here. Okay. And then one go up, cross the JW axis crossing, and then go to the zero. Another one is going down, and then go to the zero. Okay. So you must have noticed that there are 2 breakaway point. Okay, one at negative 2.88, and one is at positive. So one of this point, which is 5.28, is not exactly the breakaway point. Okay, because if you look at the root locus, it cannot go further than this zero. Okay, because zero is something like the end. Okay, the end of the root locus. So this point is just something like dummy, something like that. Okay. So this is the root locus for the question. Okay, so Lucas dah cantik sikit. Okay, ni macam buruk. Okay, but
Betul.
yeah, okay.
Dia memang kena buat curve ke macam mana?
Sebenarnya dia curve. Lucas lah macam cantik sikit. Simetri bagi dia simetri. Dia bukan straight line, dia macam melengkung sikit. Tapi ni menggeletar kan. Okay, so one more question. Question number 3 asks to find the range of K within which the system is stable. So this is basically you have to look at your Rudhowitz table that you calculate or that you done, okay, that you did. So to find stability, you need to look at the first column. Okay, so the first value of K for stability is so for stability, look at first column. So the first one is K plus 1 must be bigger than 0. So you get K bigger than minus 1. Then the next one is 6 minus 4K must be bigger than 0. So you get K bigger than, nope, K smaller than 3 over 2. And lastly, 8 plus 20K must be bigger than 0. So you get K smaller than 2 over 5 minus. Okay, so you have 3 range of K. So you need to do number lines, okay, to determine the exact range of K. So number lines minus 1 minus 2 over 5 and then 3 over 2. So the first one is less than 2.5, negative 2.5. Next one is bigger than 3 over 2. Then the other one is bigger than minus 1. Oh, ni silap. Okay, and then you need to find the intersection, the range that intersect all of the range together. Okay, so the only possible range is here. Okay, because all of the lines are intersected. Okay, so the range of K for stability is K bigger than 3 over 2. Okay, so this range here will cause the row here to become negative. So it's invalid, meaning that your K must be bigger than 3 over 2 for all of the rows here to be always positive. Okay, that's for that question. Any question from you? from you guys. All right. So if you have no question, we look at the next example. Okay, so if you look at the slide later, then the root locus is something like this, okay? So it's actually a curve. So if you can draw a smooth curve, it's good, okay? But if you cannot, then just draw roughly, okay, the shape. So tak perlu bawa protractor ke, bawa jangka lukis ke, sketch je, okay? Alright, kita rehat 5 minit. So, untuk 3/2 tu bukan K anak panah ke belakang. Oh lah. Sekejap tengok balik jawapan. Kita dah pening dah. Oh my god. Oh, nasib baik Ogi tahu. Okay, so ni anak panah ke belakang. So range dekat sini lah. Okay. So ni bukan. So range dia -2/5. K. K 3/2. Okay, thank you. Thank you, Qayyum. Okay, kita rehat 5 minit. Okay, sementara tu, if you look at the root locus, so maybe soalan komen on root locus stability, the stability of a system dalam take home quiz. Let's say kalau take home quiz tu dapat root locus yang macam ni. So apa benda nak komen dari root locus ni? So actually root locus is a plot of the poles when you increase the value of k or the gain k. So at poles here at x, basically k equals 0. So here at this point, k equals 0, and also this point. And at the zeros is the point where k is at infinity. So instead of finding the value of poles for each k one by one and do a table, so you do a rough root locus sketch, okay, which is faster, okay, than finding the poles for each k value, which is you are required to do a lot of calculation. So when you look at when you know that at poles the k equals 0 and at 0 the k equals infinity, then you will see that then you can comment on the stability of the system. So you can say that the stability of the system is stable as k is increasing from 0 until this intersection here at JW crossing. So at JW crossing, you already found just now the value of k. So the value of k at JW crossing is this one, okay? 3/2. So meaning that the stability of system the system is stable at from k equals 0 until k equals 3/2. But as k increase more than 3/2, then the system becomes unstable. Okay, because the pole or the root locus is on the right hand side of the S-plane, while before k equals 3/2, the root locus is on the left hand side. Okay, so maybe in the take home quiz, you can say that you can comment on how the stability probably looks like. Okay, because the other method that you can determine the stability is by uh, finding the time response for the system at each point of the root locus. Okay, but that's also tedious. You need to do more work. Okay, or you can use MATLAB. So that's why you only give comment based on the root locus. So if let's say you are given this question, let's say this graph, this root locus, and then ask you to comment, then just comment that the root locus, the system is stable until this point, and then after that the system is unstable. Okay, because it's already the root locus is on the right hand side of the S plane.
So, nak tengok range tadi jap.
Okay, so let's look at the next question. Okay, next question is actually a quiz. So I call it quiz kejut. So 25 marks and submit this Sunday, but I will discuss it now, okay? So there are 3 quizzes that you need to submit by Sunday. Quiz and okay, 2 quiz, which is the take home quiz and also quiz kejut. Okay, so this quiz, the same type of question as previous question that we have discussed. So you are given a unity feedback system with GS as the forward transfer function. So the question asks you to sketch the root locus, find the imaginary axis crossing, and value of k. So these 2 questions basically the JW axis crossing, and then breaking point or breakaway point, and then the range of k for stable system. Okay, so if you get later question on root locus, it is better if you can find this 4 question first before sketching. Okay, sometimes when you sketch, you don't know where is the JW axis crossing or where is the breakaway and breaking point. So try to do this 4 question first, and then after that you sketch the root locus. Okay, so the transfer function is GS Okay, and then first step is to find the poles. So the poles, you need to look at the denominator. So here you will get minus 3 plus minus 4j. And then zeros, you need to look at the numerator. So the zeros will be 2 and 4. And since you have 2 poles and 2 zeros, so you don't need to add infinity. And here you know that there are 2 branches. Okay, so from here you know that there are 2 branches of the root locus. And then the next question asks you to find the JW axis crossing. So for JW axis crossing, you need to use Route-Hurwitz criteria, Route-Hurwitz table. So before that, you need to find the closed loop transfer function. And since this is unity feedback, so the closed loop transfer function will be so you only take the denominator. So the denominator will be and then you can start drawing the Route-Hurwitz table. Okay, so from the denominator, k plus 1, 6 minus 6k, and 25 plus 8k, and then 0. So to determine S naught, you use determinant, the determinant rules. So you get 25 plus 8k, 0. Okay, and then to determine the gain k for at JW axis crossing, you use row S1. Okay, use S1. So the gain k equals 1. And then use this k value into row S2 to find the point, the frequency at JW axis. Okay, or to find the imaginary axis crossing. So there are a lot of names, maybe frequency, a damping frequency at JW axis crossing, or maybe imaginary axis crossing, or maybe the name can be the frequency, the damping frequency at for marginally stable system. So there are a lot of names, but you are actually finding the same thing, okay? Finding the JW axis crossing. So use row S2. You get 2s squared plus 33 equals 0. So substitute 1 here and 1 here, and then write in terms of polynomial. Then here you get s equals plus minus 4.06 j. So this is the imaginary axis crossing. Or frequency at marginal stability. And then the next question is to find the break-in and or breakaway point. Okay, so break-in and breakaway point. So we use the sum formula. So 1 over s minus 2 plus 1 over s minus 4 equals minus 3 plus minus 4j. So you get 1 over s plus 3 minus 4j plus 1 over s plus 3 plus 4j. Simplify, you will get okay. And then you simplify, you will get 12 s squared plus 34s minus 198 equals 0. And then find s. So s equals minus 5.77 or 2.86. So there are two breakaway or break-in point. And then we sketched the root locus. So because we have all the information needed. Okay, so the poles is at minus 3. The poles, yeah, minus 3 plus minus 4j. 1, be somewhere here. So somewhere here. So the pole is here and here. And then the 0 is at -2, +2, and +4. So here and here. And then your JW axis crossing is at 4.06. So somewhere slightly here. And then the breaking points at -5.7. Maybe here. And another one is 2.86. So somewhere here. Okay. So you know that there are two branches for the root locus, and it must start at the poles and then ends at the zeros. And it must be symmetry about real axis. So you can sketch them by maybe the root locus moves from here, and the only possible direction it can go is towards the 0. Okay, 0 is here, so it cannot go to the left. Okay, because if going to the left, then it cannot meet the zeros. So the only way possible is to move backward. Okay. Okay, so it must cross the JW axis crossing, and then goes into the breaking point. So this is the breaking point. And then after that, the root locus, one of the root locus will split going to this 0, and the other one will go to this 0. Okay, so let's sketch. Alah. Okay, anggaplah dia kat sini. Boleh bawa apa-apa je lah. Okay, so this one. Okay, so one of it will go to this 0, and one of it will go to this one. Okay, so this one must meet at this point. Okay. Saya lukis buruk, nanti korang lukis yang cantik lah. Okay, so for the quiz score kejut, I want you to answer the last question, the range of K for the system to be stable, and also find the angle of departure for imaginary poles. Okay, so two more questions that I want you to do by yourself. Okay. So that's it for root locus. So next week we will go into chapter 5, something about plotting, also about plotting, but a different representation of the transfer function. We represent the transfer function in terms of frequency, and also one of the plot we represent the transfer function in terms of magnitude and angle. And from that sketch, we can also determine the stability. So there are two more plots, and then next week is week 12, and the week after is week 13. we will go into chapter 6, the last chapter, which is about PID controller. And after that, inshallah, maybe week 30 will be our last class. And maybe, I don't know about your final exam. Maybe those who are in final year will have your exam first before those who are not final year. So maybe we can do revision class maybe somewhere in study week ke, okay, and then maybe one more revision class for those who take the final exam, the second batch, okay, that's it for today's class. And if you have any question, you can ask me. And remember to submit your take home quiz, take home quiz number 4, whatever, and also quiz kokojut. Okay, that's it for today. Assalamualaikum.
Oke, dokter. Terima kasih. Assalamualaikum.
Bye.
Bye.